Oh, I can say no. Hey dear friends, is 5G radiation dangerous? That's what we'll talk about today. I was born at a time when there were no smartphones, not even mobile phones. In fact, there weren't even cordless phones. Today, we are surrounded by mobile technology, and this shows us that information technology is evolving very quickly. Look, here is a phone that only had voice and messages, no data, and here is a data phone using 3G technology. And this one I'm using today is a phone that uses 4G technology. And now people are talking about 5G technology. What's the difference? Well, from one generation to another, the phone's ability to transmit and receive mobile data increases. 3G, for example, transfers a few hundred kilobits per second, 4G transfers hundreds of megabits per second, and 5G will transfer tens of gigabits per second. Basically, with 5G technology, you can download a regular movie in less than a second. Now the water is dripping. That's the analog of 3G technology. Now the water is flowing. That's 4G technology. Don't give it. And now the water is gushing powerfully. That's the analog of the technology. 5G. Do we really need gigabit per second transfer speeds on mobile? Personally, I don't need it. And I download videos offline. That's why some people say we don't need 5G. Still, I don't agree with them. Any new technology generates things you don't think about. Let's take, for example, future smart driverless cars, because they will definitely become a reality. To drive by themselves without causing accidents, the cars will have to communicate efficiently with each other and with command centers, from where they will download maps with the exact situation. At some point, it's clear 5G technology will be useful here. Let's think that in the future, artificial intelligence will explode. For it to train and function properly, artificial intelligence needs a lot of data. The smartphone of the future, if it uses artificial intelligence, will take full advantage of the high data transfer of 5G technology. Simply put, it's not about how fast we download movies on our mobile phones, but about the new technologies that will fully take advantage of the benefits of 5G networks. Any technology comes with both opportunities and risks. Let's take this one as an example. This microwave oven, did you see? It can be dangerous, just like the cart. I had a friend who was kicked by a horse when he was a child. The car is dangerous. If you drive it, you can have an accident. Even the mobile phone can be dangerous. If you walk while looking at your mobile phone, you can fall into a hole. It's the same with 5G technology. The fact that it comes with risks is natural. We need to identify them and then say which of the risks are unnecessary and which are useful. Driving a car, for example, is a useful risk, while high speed just for the sake of speed is an unnecessary risk. The risk most often talked about with 5G technology is radiation. It is said that its radiation could cause us cancer. Is that true? Let's start with the word radiation. People hear that 5G has radiation and get scared. Why do people get scared? Because they believe that radiation is inherently dangerous. They forget, or maybe they don't know, that not all radiation is dangerous. Visible light from the sun, for example, is radiation. Is it dangerous? Not at all. In fact, it's called radiation because the sun radiates energy. That's what radiation is basically. A beam of waves or particles that carries energy. This. Even a light bulb in the room radiates. It's the light radiation that reaches us. Of course, it's not dangerous. Similarly, the electric wires that bring electricity to the bulb radiate electromagnetic energy at a frequency of 50 Hz. For more than 100 years since we've had these things in our homes, it hasn't been proven that they're so dangerous. That's why we don't need to throw out the light bulb and sit in the dark out of fear of radiation. I'm waiting. So, not all radiation is dangerous, however, which ones are? Cosmic radiation, for example, is dangerous. They are made up of high-energy particles that, if they hit the atoms we're made of, literally break them apart into pieces. Because the atoms lose some of their electrons this way, the atoms become ionized. These radiations are called ionizing. It's normal to avoid such radiation because it damages the atoms and molecules that make up our cells. In the end, this wonderful but extremely complex machine that is the body often gives in, leading to cancer. However, we will not refer to radiation made up of particles, but to radiation in the form of electromagnetic waves. Because we want to talk about 5G technology, and the radiation emitted by mobile phones is electromagnetic waves. What are electromagnetic waves? Electromagnetic waves are oscillations of electric and magnetic fields. They are arranged according to the frequency of the oscillations. We have electromagnetic waves of 50 Hz, for example, given by the power grid. That means they oscillate 50 times per second. We have radio waves of 100 MHz, for example. That means they oscillate 100 million times per second. We also have visible light, which is also an electromagnetic wave with a frequency of 700,000 GHz. Of course, we also have X-rays with an even higher frequency. We are interested in microwave ovens that generate 2 GHz waves, and mobile phones from the 3G and 4G generations or Wi-Fi networks, which also oscillate at a few GHz. The new 5G networks use frequencies of up to 70 GHz. Okay, looking at this wide spectrum, where do the dangerous electromagnetic waves come from? Let's start by identifying which of the electromagnetic waves can be ionizing radiation, because we know those are more dangerous. For that, we need to calculate which types of radiation can knock electrons out of an atom's orbit, breaking them apart. There are all kinds of atoms and all kinds of energies, but we get an approximately correct order of magnitude by calculating the ionization energy of the hydrogen atom. The ionization energy is the energy needed to remove the electron from its orbit. The formula is the one shown here. We substitute the constants and get approximately 13 electron volts, which is 2 times 10 to the power of minus 19. J. Which of the electromagnetic waves can reach this energy and which cannot? We must remember that electromagnetic waves consist of discrete energy packets called photons. The energy of a packet is given by the formula E equals h times f, where h is Planck's constant and f is the frequency of the wave. The frequency of the packet is then f equals E divided by h. We substitute into the formula and get a frequency of 3 million GHz. Waves with a frequency higher than 3 million GHz are ionizing, and those with a lower frequency are not, because their energy packets don't have enough energy to knock electrons off their orbit. If we look at the adjacent graph, we'll see that this limit, calculated here in a very simplified way, is around ultraviolet radiation. These, together with X-rays and gamma rays, have enough energy to ionize atoms. That's why we need to protect ourselves from such radiation, for example when we're sunbathing under the sun's ultraviolet rays for a long time. Now let's add mobile phone technologies to our table. 3G and 4G technologies use frequencies up to 3 GHz. 5G technology will use frequencies up to 70 GHz. However, this is far below the 3 million GHz at which electromagnetic waves become ionizing. In other words, 5G radiation is not ionizing and it will not break atoms. This means that, in principle, we do not expect it to pose high cancer risks, at least from a theoretical point of view. The same would be true for 3G and 5G radiation. This result is supported by medical studies. Let's look at the cancer rate over the last 50 years. We'll notice that it doesn't increase suddenly, with microwave ovens introduced. 50 years ago, or with the introduction of mobile phones and Wi-Fi networks 20 years ago, the cancer rate has remained roughly constant. Of course, This doesn't mean that electromagnetic radiation from mobile devices doesn't cause cancer at all, especially under critical conditions of a sick body. These studies only mean that any potential cancer rate caused by mobile phones is not high enough to show up very clearly in medical studies. That's why American medical authorities have classified mobile phone radiation as possibly carcinogenic. Hearing the two words possible and carcinogenic together and not knowing exactly what they mean, many people got scared. Many people don't know that in the same possibly carcinogenic category, for example, aloe vera is also included. In all the above cases, possible means something with a very low probability. Let me give you an extreme case from physics. In quantum mechanics, it is possible for me to quantum tunnel into the next room through the wall, but that is not probable. There is a huge difference between the word possible and probable. The conclusion we draw from this is that there might be a risk of cancer, but the risk is very small, and we shouldn't be scared. Considering that mobile phone technology is very useful to us, we can classify the risk as a useful risk, just like a cart, a car, or an airplane. And the second conclusion is that it's good for researchers to continue studying the effects of mobile phone radiation to make sure that this risk remains low. 5G technology using radiation of up to 70 GHz, which is much less than the 3 million GHz, falls into the same category as 3G and 4G technologies. When it comes to cancer, how will it affect the body? Essentially, just like the 50 Hz radiation from power grids, or the 2 GHz radiation from mobile phones, or the radiation from microwave ovens. All of these heat up the body. The basic idea is as follows. Mobile phone radiation is an electromagnetic wave. The wave is made up of varying electric and magnetic fields. On the other hand, objects also contain dipole molecules, meaning that in these, the electric charges are slightly separated in space. A dipole molecule placed in an electric field will align itself in the direction of the electric field because the two electric charges will be pulled in different directions. When the electric field oscillates and changes direction, the dipole molecule tries to align itself with the field, switching directions as the field does. In this way, it starts to vibrate and move around, and this agitation is thermal motion at the microscopic level. This causes the temperature to rise where the electromagnetic wave arrives. That's what happens in the microwave oven, which is specially designed to increase the temperature of the food placed inside it. But wait, you might say, we know standing inside a microwave is a very bad idea. Who hasn't seen food explode in the microwave when left in too long? It's normal for that to happen. If the food in the microwave is heated for a long time, the water inside can reach temperatures that exceed 100 degrees Celsius. It evaporates, creates pressure, and can explode in places where the temperature is higher than 100 degrees Celsius. That's why the microwave oven has a very interesting feature. When I open the door, it stops. It stopped precisely to protect me from the electromagnetic radiation inside, which otherwise could have reached me. Moreover, if you look at the microwave oven door, you'll notice something very interesting. It has a mesh integrated inside it, which is actually a metal mesh. This metal mesh acts as a Faraday cage. So when the door is closed, we can look inside. And from the inside, the electromagnetic field can't escape because it's blocked by this mesh, by this Faraday cage. Just like, for example, the field can't get out unimpeded, but the audience from outside, the action or something, comes out to the people, the Redeemer, the truth. So then, if the microwave oven heats things up, the radiation from mobile phones should do the same, right? Because it shares the same frequency, of course. That's why mobile phone manufacturers have to prove to us, before putting a product on the market, that their devices are not portable microwave ovens. They have to prove that the radiation intensity is low enough not to significantly increase the temperature of the human body. That's why. If we see an infrared measurement showing how after half an hour of talking on a mobile phone, the temperature in the head area increases, we need to ask ourselves two things. First, did the temperature increase significantly, let's say by 1 degree? And second, if the effect is due to radiation and not the heated battery, if it's radiation, we need to notify consumer protection because that mobile phone has broken the rules. In this regard, 5G technology actually has an advantage over 3G and 4G technology. Its radiation, if it heats up a little, only heats the skin and not the organs. In other words, the temperature increase, which should be small anyway when standards are met, only affects the surface of the skin. Why? Let's see with a bit of physics. I mentioned the Faraday cage. Essentially, a Faraday cage is any metallic surface. Through it, the electromagnetic field doesn't pass. Why doesn't it pass? Because the metal has mobile electric charges, electrons for example. The electromagnetic field sets these mobile charges in motion. In their movement, they generate an opposing electromagnetic field, which cancels out the initial electromagnetic field. The electromagnetic wave won't pass through the metal wall. Where? Just like in the case of the microwave oven, no conductor is perfect though. That's why the more imperfect the conductor is, the more the electromagnetic field penetrates it. The distance that the electromagnetic field penetrates is called the penetration depth. It is calculated by knowing the conductivity of the conductor. Water, for example, has a conductivity of around 0.110 Siemens per meter. Skin, on the other hand, contains a lot of water. Similar to the human body, that's why the composition of skin is close to that of water, about 0.1 Siemens per meter. This means that the skin, like the entire human body, is a good conductor of electricity. That's why we can consider the skin as a fairly reasonable Faraday cage. With the skin's conductivity and radiation frequency, we can calculate penetration depth. I used a website to calculate the value. For 70 GHz radiation, I got a penetration depth in the skin of about 2 meters. The actual value is about 8 mm since the radiation decreases exponentially rather than stopping abruptly. The result, however, is that the skin really does work like a Faraday cage. And the 70 GHz radiation from 5G technology will hardly reach the internal organs and will not heat them. All it will do is heat the skin. To conclude the physics part, we see that the radiation from 5G technology is not much different from that of previous 3G and 4G technologies when it comes to the physical effects on the body. Thus, the quantum energy packets of the radiation do not have enough energy to ionize atoms, and that's why they are not an obvious cancer risk. They can heat the body, but only the skin. The important thing is that they don't heat too much, and that's what the authorities and regulators take care of. Let's note an interesting fact. I said that a packet of radiation energy, a photon, cannot ionize an atom because it doesn't have enough energy. Its energy is 100,000 times less than needed. But if we put 100,000 energy packets, 100,000 photons into the same atom, then we still couldn't ionize it. After all, we learned in school that where there's one, there's no strength, but where there are two, the strength increases. That's a human rule that doesn't apply in physics. And the reason is the photoelectric effect, explained by Einstein, for which he received the Nobel Prize. Let's go into detail using the painstaking drawing. The quantum energy packets of radiation, the photons, come to the atom one by one. When a single energy packet arrives, it looks around, sees that it doesn't have enough energy and moves on. It sets the atom in motion a little, meaning it heats up the material. When a second packet comes, it also looks around, sees that it doesn't have enough energy and moves on. Again, with a lower probability, it can set the atom in motion so it can heat it up. If two energy packets come, two photons at the same time, they ignore each other. Each looks at the atom, says it doesn't have enough energy, and moves on. There can be 10,000 photons coming at the same time, 100,000. Each one thinks it's alone and moves on, lacking enough energy. Eventually, they can move and heat the atom. But photons never actually combine their powers in practice. As I said, one alone has no power, but two together have more, except in the quantum world where this doesn't apply. That's why, no matter how intense 5G electromagnetic radiation is, it won't cause atoms to be ionized. It will just heat up the place where it's absorbed more. The conclusion of this video: for now, based on physics, we don't expect 5G radiation to pose much greater risks than 3G or 4G radiation. These in turn have not been proven to be dangerous, and that's why we have no reason to be afraid. Of course, that shouldn't stop us from staying alert and monitoring any side effects. But that doesn't mean we should create a mystery. Instead, we need to weigh the various risks. We need to strike a balance. Before banning all mobile phones out of fear of radiation, we should ban unhealthy food, which leads to obesity and carries a much higher risk for cardiovascular diseases. Are we ready to give up fatty pork meat eaten in excess or fast food consumed several times a day? Are we ready to give up salty foods, which have also been proven to raise blood pressure, or at the extreme smoking? Only then can we consider giving up mobile phones for our health. So, you see, our health is affected more negatively by the poor choices we make than by the radiation from mobile phones. Do you want to learn more about physics? Read Storytelling Physics. Here you will find advanced physics explained in a way you can understand. Einstein's theory, mechanics now.